Hello, everyone. So this is the last session of the day. Thanks for sticking around. And I'm going to talk about gRPC. But before I start my talk, a little bit of information about myself. My name is Mete Atamel. I'm a developer advocate for Google Cloud Platform. I'm based in London. What a developer advocate means is that basically I come to conferences and give talks about Google Cloud-related technologies. I also try to talk to developers, get their feedback about Google Cloud, and bring that back to engineering. So if you are using Google Cloud or if you have any questions, feel free to let me know. This is my Twitter and my email. So even after today, again, if you have any questions about the talk today or about Google Cloud in general, feel free to let me know. So the agenda we have today is, first I'm going to do a little intro to RPC. I mean, most people probably know about RPC here, but we'll make sure that everyone is on the same page. And then after that, I want to talk about a story of building an RPC system. Because in one of my previous jobs, I actually built an RPC system. And I think it's important to talk about it because it's hard to appreciate a framework like gRPC if you don't know what goes behind the scenes in an RPC system. So by going through that story or building that system, hopefully you'll get to appreciate what gRPC provides to you. So once we cover that, we're going to talk about what is gRPC, what does it actually provide to you. And then I'm going to show you some code. And then after the code, we're going to talk about the benefits of gRPC, so what it actually gives you on top of the features, like what's the underlying themes, like HTTP2, multi-language support, stuff like that. And then finally, if we have some time, we'll look at some more code. So this is the agenda. So what is remote procedure call? I just want to cover this so that people are all on the same page. So normally, this is a regular procedure call. So imagine you have a greeter service that has a say hello method. And it's very simple. It takes in a text as string and returns a string as well. And if you want to use this from a client, let's call it greeter client, you can create the service, and then you can just call the method on it with the parameter, and that's it. You know, this is what we do, and everything is in the same machine. That's the box. It's the same machine. And you know, this is simple. Life is simple. Now, RPC, Wikipedia definition is this. So RPC is a protocol that one program can use to request a service from a program located in another computer in a network without having to understand the network details. There are two key things here. One is you have two computers now. You don't have everything on the single machine. And you want to make a call from one machine to another machine. But the key thing is that you want to make that call in a way so that all the details of the connection are abstracted away from you. So you don't care as the client, you know, how the connection is being made, what the state of the connection is. You just want to make that call as if it's local. So that is what RPC is. It's like it's a procedure call as if it's local, as if it's on the same machine, but it's not local. It's on another machine. But the RPC framework takes care of abstracting all of that complexity from you. All right? Now, so our simple example, now it kind of looks like this now. So you can call it machine 1 and machine 2, or you can call it client and server, whatever you prefer. But you have the servers running on a different machine with the method, and then you have the client, and the client needs to call that service, right? Now, conceptually, this is simple, but if you think about it, there are many things that you need to answer now. For example, how do you expose that service? How do you tell to the world that I have this service and it has this method, and people can call this method? How do you make the client be aware of that service? Once the client knows that service exists, how do you make that connection? How does that look like? You need to also send some text to the service, right? So how do you serialize that? Because at the end of the day, what you need to send over the wire is just bytes. So how do you take your text, convert it to bytes? What does that encoding look like? So even though conceptually it looks really simple, there's all these questions that comes up that you need to answer. Now, at this point, I want to switch to my RPC story. So the motivation of this story is to tell you a system that I worked on, where we built an RPC system, and then through that, we'll see all the complexity that comes with RPC systems. So this was back in 2006. I had my first job out of college. I was working for 1 year. But then the job was a software engineering role, but it turned into more like a support engineering role where I was kind of on call all the time, and I was responsible for services that I didn't write, and people would call me in the middle of the night and say, this service doesn't work, can you fix it? So I had enough of that job. And then around the same time, someone from Adobe calls me and says, we have this new thing called Adobe Flex. I don't know, do you guys know Adobe Flex? Yeah, you remember, yes. Yeah, Adobe Flex was great. So the goal of Adobe Flex was, Flash at the time was virtually on every single device, but it was mainly used for games. And Adobe wanted to turn that into a platform so that people can write applications in Flash. So not just games, but applications. And they created this notion called rich internet applications. Because back in 2006, HTML and JavaScript was really basic. And Flash is really rich. You can have great UI with Flash. And using Adobe Flex, they created all these components and all these things to actually build rich internet applications. So that's the team that I started working. And of course, with every client, you need to connect to some server, right? So J2EE at the time was really popular. It was like kind of the main thing that people did. So there was this other product called Flex Data Services. I don't know if people know about that or use that. But basically, it was a J2EE application that you could drop in your app server, and it would make the connection from Flash, your Flex client, to Java backends. Now, to make the connection, we had to build an RPC framework. So I just want to go through that process and tell you the design decisions and all the new constructs that we had to create to make the RPC system. Now, the first thing is, so we have the J2EE server with the service that we want to expose to our clients, but we also, in a typical use case, you also have some private services. You don't want to expose everything that you have on your server by default, right? So when you have these services and you have your Flash client to talk to that service, how do you actually define what's public and accessible to clients and what's private, and it should stay private? So the first thing that we had to create was the notion of destinations. Destinations was an XML configuration that you could define on the server. And in this XML configuration, you would basically say, these are my services, these are the public methods that you can call. And then by listing it in these destinations, you're basically making them public to the world. And then this destinations XML would also be baked into the Flash client. And then the Flash client will use this destination and contact the server. So this was the first notion, destinations that we created. Now, you know the destinations, but you need to make a call to the servers. So I don't know if you guys know about ActionScript. Has anyone used ActionScript before? Yeah, great. I still love ActionScript, even though I don't use it. I think compared to JavaScript, it's much better. It's strongly typed. It's unfortunate that it's not used that much anymore, but ActionScript was the main language for Flex. So in ActionScript, we created this thing called remote object. So what you would do is you would create a remote object and specify the destination that you want to talk to. And then you would just call a method on it as if it's local. So you would just say remote object.say hello and pass in your hello. And actually, this remote object, it was a proxy object. So it didn't really have this say hello method. What we would do is that we would intercept a call and create a remoting message with the metadata. So the remoting message will have, destination ID. It will have the name of the method, and it will have the parameters. And we will serialize that remoting message, send it to the server. The server will get this message, deserialize it, and then it will check the destination ID. If it exists, it will forward it. If it doesn't, it will send an error back. If the destination exists, then it will check for the method that you wanted to call. So if say hello exists, which exists in this case, it will let it through. If it doesn't exist, it will return an error. And then it will also look at the parameters. So if you passed in a text, then it will pass it through. But if you passed in, let's say, an integer, it would complain about it. So we created remote object. We created remoting message. We had to serialize these remoting messages, and then we had to deserialize them. We had to add all this error checking on the server side. So as you can see, there were a lot of things that we had to implement. But life was good. We made the connection from Flash to Java world, and it was simple enough to use it, and we were happy about it until the product manager came up with a new requirement. So our product manager at the time told us that, this is great. Now we can talk from Flash to Java, and we can pass in objects. We can expose methods on the server side. That's great. But we have financial services customers, and financial services customers, they want to stream a lot of data from server to client, client to server, because they had to do like stock applications where there's like topics and subtopics, and people subscribe to those topics and get stock updates, stuff like that. So he said we need something new, not just remote object, but we need streaming and we need pub/sub messaging. That's what we need. So we had to go back to the board and design that. So what we designed is this. So we created topics and subtopics. So if you guys know about JMS, it's similar to that. And we also created these new two constructs, consumers and producers. So the producer will talk to a destination. This time it's a messaging destination. And then it will send a message. And then the consumer will subscribe to a destination and get updates. So the new constructs here is that the consumer, producer, the messaging messages, and these topics and subtopics. And we were also using AMF. So for the encoding, we could have used XML. That was like the main thing at the time. But we use AMF, which stands for ActionScript Messaging Format, I think. It's a binary protocol. It's much more efficient than plain text. So that's what we decided to use. And we were using HTTP as well. Now, the problem in this case was that, how do consumers get messages? Because in remote object case, you make a request and you get a reply, and it's simple. In consumer, you subscribe to the destination, but you need to somehow get those messages when the producer sends the messages, right? So in that case, you have two choices. You can either, as a consumer, ask for messages in a periodic time, or the messages can be pushed to you somehow. But for that to happen, you need a TCP connection. Just HTTP connection wouldn't work in that case. The other thing we had was, okay, we are using HTTP, but can we use something else? Because in streaming cases, you really need a TCP connection. And at the time, Flash had a protocol called RTMP, I think, which it stands for Real-Time Messaging Protocol. That is mainly used to send videos, but we also thought we could use that for data as well. So, maybe instead of HTTP, we could use RTMP. So all of these choices, they led us to another construct called channel. So we said maybe we need channels to define all these different choices that we could make for the connection between the client and the server. And then we created lots of channels. So we created HTTP channel for the regular request and reply. We created HTTP polling channel where the client asks for messages every X seconds. We created long polling because polling is not efficient. You poll every 3 seconds. If you don't have any messages, you're just wasting requests. Whereas in long polling, you poll, and then if there's no message, you keep the connection open until you have messages. So we created that. We created HTTP streaming, which is a server-to-client connection. So the client makes a connection, and the return is kept open for the server to push messages. It works in some cases, but in some cases, like load balancers, they don't like it. But for customers who could use it, we implemented that. We used RTMP. So RTMP was basically a TCP connection between Flash and the server. And then later, after like a year or so, WebSocket came along. So the WebSocket is the real-time HTTP protocol, which is also a TCP connection. So when that came along, we also implemented that. So in the end, this is what we had. So we had, for messaging, we had consumers and producers. For remoting, we had remote object. On the server, we had topics and subtopics. Then we have our services that we would expose through destinations. Then we have different channels, RTMP channel, HTTP channel, long polling, streaming, all that kind of stuff. For encoding, we would use AMF. And then we have all these different kinds of messages, remoting messages, and messaging messages going over the wire. As you can see, it's getting complicated. But life was good again, Like we could do a lot of things here. Like and we had lots of customers doing different things using this framework, and it felt good. Until this guy came along. And I don't know if you guys remember, but in 2010, Steve Jobs came up with a public letter, and it's still public. It's still on the web, and you can read it. And it said, the title was Thoughts on Flash. So basically, he wrote a letter explaining why Flash wouldn't be on iPhones ever. He had some good reasons, because the performance of Flash on mobile wasn't great. Some of his points were kind of exaggerated, but either way, the big point was that Flash would never be on iPhones, and for the world, I mean, the world was moving from desktop to mobile at that point, so that was a big blow for Adobe and Flex and stuff like that. So what happened afterwards is that Flex basically slowly started disappearing from mobile. The Flex framework and the Flex data services that I was working on, it was open source, but then they really didn't go anywhere. I think they lost momentum. Even Adobe, they shifted focus from Flash to HTML and JavaScript. And as for me, I moved to another company. I'm working on different problems, not Flash related. But the thing is, I still had problems to solve with RPC, you know? So when I started working in this new company, I was back to square one. You know, I had to answer these questions, like how does a client call a service on a remote machine? How do you expose the service so that the client knows about it? How the data is serialized and deserialized? What's the nature of the call? Is it HTTP? Is it TCP? Is it WebSocket? What is it? Authentication, how do I do the authentication? So all these questions that I asked and implemented in Flash, they were gone. Like I couldn't use Flash anymore. But I had to answer them again. I had to implement them again. So I felt like I went back in time, basically. So at this point, you really have two choices with RPC. You can build your own custom RPC framework. You know, if you have the time and if you want to, you know, invest time and effort into it, you can build it. And the good thing about that is that it is exactly how you want it to be. So when we were building the Flex data services and the RPC framework there, we really liked it because we started from scratch and built this thing, and it felt beautiful because it is exactly how we want it to be. But the disadvantage here is that, as you've seen, like when technologies change, things are, like you need to answer all these questions that I talked about, and when technologies change, then you need to re-answer those questions and build code again, and that's not so great. Thankfully, there is another choice, which is gRPC. So gRPC, it's a high-performance open-source universal RPC framework that's out there that you can use. The good thing about that is that it's all the questions that we asked here, they're already answered and implemented in multiple languages for you. So you don't have to answer them. You don't have to think about them. They're already there. The disadvantage is that gRPC has a certain style that you need to get used to. So you need to like that style, and I'll show you some code how that looks like. So you need to adapt to that style, but that's okay because in every software reuse case, you need to like, or you need to at least adapt yourself to what you're using. All right, so this is gRPC, but at this point you might ask to yourself, why don't we just use REST? You know, like we know HTTP REST, it's well understood. You know, the HTTP verbs like get, post, put, delete, they're usually rich enough for the things that you want to implement. So why don't we just go with that? And my answer to that is, you know, if REST is good enough for you, go ahead and use it. You know, it's simple. There's many benefits of REST, like, you know, it caches really well, things like that. So if you can use REST, use REST. But when you think of complex scenarios, imagine you want to do like a bank transfer. You want to transfer money from one bank account to another bank account. If you want to do that with REST, you can probably do it. But you'll probably need like multiple REST HTTP requests, and the client has to worry about, you know, making these HTTP requests, making sure that they succeed. There's lots of details there that the client shouldn't care about. Instead, if you use RPC, you can create a bank service, and you can have a method on it that says transfer from this account to this account, that amount, and you can abstract away all this complexity using RPC. So that's what I like about it, is that in complex scenarios, it helps you to abstract and make it look like it's a local call for the client, even though it's not local. And the second thing I like about RPC is that it's strongly typed. So the client using stubs, talks to the RPC service using a strongly typed object. So the client doesn't have to worry about creating HTTP requests. It only cares about talking through the stub. And I'm going to show you some code shortly to let you know what I mean. All right, so this wraps up the first part of the talk where I kind of give you the motivation of why gRPC. So as you've seen, like, there's a lot of details that you have to implement yourself if you have to do it yourself. Or you can rely on gRPC and let gRPC do the heavy lifting for you. So in this part of the talk, I just want to go through the details of gRPC. So gRPC, as I mentioned, it's an open source project, but it actually came from something called Stubby. Stubby, it's an internal RPC system used at Google, and it's used to do, I guess, 10 billion, whatever that number is, RPC calls per second. So it's used a lot at Google. So what we did is that we basically looked at Stubby, and Stubby is really tightly coupled to our internal system, so we couldn't just take it and make it open source. But we basically looked at it and said, okay, what did we learn from Stubby, and how can we take Stubby and bring it to open source so that other people can use it as well? So gRPC basically came from Stubby. So the team who worked on Stubby, they created gRPC using the learnings from Stubby. So in that sense, it's the best of both worlds. So gRPC is open source, but it didn't start from scratch. It came from this Stubby project that we use a lot internally. And the goal of gRPC is basically we want gRPC to be really efficient, because if you are making 10 billion calls per second, every millisecond counts. So we make sure that the connection is really efficient. We make sure that the encoding over the wire is really efficient. We want you to be able to use gRPC no matter what language you use. So multiple languages are supported. It's performant and scalable. And also microservices. I mean, you probably heard a lot about microservices here and in every Java conference that we go to nowadays. We are breaking down our monoliths into smaller microservices. But then the problem that you have with those microservices is that they need to still communicate. So you want to make sure that the communication is really efficient. So gRPC is actually designed for that. So, and I'm going to show you what I mean with examples. But basically, when you have microservices, and if you use gRPC, the connection and the serialization over the wire and everything about it is really, really designed for that. So this is one slide that basically tries to summarize gRPC, like in just one slide. First, what you have in gRPC is a service definition. So in this service definition, it's a protocol buffer definition. You define what your service is, and you define what your methods are on that service, and what these methods take, like what are the inputs and outputs. I really like this because by just looking at the service definition, you can get an idea of what your system is. So you don't have to look at the classes, you don't have to look at the generated code, you just look at the service definitions, and from there you get an idea of what your system looks like. And I'm going to show you some of these later. So from the service definition, you generate code. So you generate client-side code and server-side code. And this code can be generated in like 10 plus languages. This is also great because you don't start from scratch. You get like a starter code that's given to you by gRPC, and then you can just extend from that code and get started with that way. In terms of serialization, it uses protobuf. So protobuf is the efficient binary serialization format. So that gives you efficiency in what goes over the wire. But also the connection you use is HTTP2. So HTTP2 is designed for making user feel like latency is good. And actually there was a talk, I think it was like last hour, that talked about HTTP2. But it basically tries to use HTTP2 for the connection, so you get the efficiency in connection as well. And then for the actual connection itself, you have multiple options. So you can have unary connection, which means request and reply. But you can have server-side streaming, you can have client-side streaming, and you can have bidirectional streaming. So imagine a chat application, for example, where the client and the server, they have to send messages to each other. You can have that as well. And then for authentication, you can have multiple options like SSL and token-based authentication. So as you can see, like all the questions that I asked earlier, they have answers to them, which is nice. And then if to look at it in a graphical way, so you, as I said, like there are multiple languages support. So you might have a C++ service and a Ruby client, an Android-based Java client. You generate code stubs, client stubs that the client uses, and then you also get some boilerplate code for the server. So once you have these codes, then you can just extend from them. And then the stub talks to the server using Proto, makes a request, gets a response, stuff like that. All right, so let's look at some code now. So imagine the hello world case that I talked earlier, where you have a service called hello world that takes in a text and returns the text. If you want to implement that in gRPC, how do you do that? So I'll show you that here in 4 steps. First, you need to create the service definition file, as I mentioned. So the first thing you do is you create an example service.proto. Here, we are saying that we have a service called greeting service, and then it has a RPC method called say hello, and it takes in a hello request and returns a hello response. So it's very simple, just one method, and it has one parameter and returns one parameter. Now, of course, we need to define what the requests and responses look like. In this case, our request is a message, and it has a string name. So it's basically just a string. And then it has a response, which is also a string. But these requests and responses, they can be complex objects, and I'm going to show you an example of that. But for this example, you're basically taking a string and returning a string. So once you have this proto, you define your service. From here, you generate code. So if you are a Maven user, there's a protobuf Maven plugin. And if you are a Gradle user, there's protobuf Gradle plugin. So using these, you just point to the service definition file, and this creates the client stubs and some server code for you to extend from. The third step is to actually create the server. So the server implementation, it's really easy. You just extend from the generated base class that the protobuf generates for you. And then you specify the port, and then you also specify a service implementation. So you need to actually define what the service does. So that's the service implementation, and you start the server, and that's it. So the 3 things here is that you extend from the base class, you specify the port, and then you define the actual service itself, and then start the server. And then the last part, sorry. The last part is creating the actual client. So the client is a little bit more complicated because you need to actually define how you're going to connect to the server. So for that, they also have a notion of channel. So you create something called a managed channel for the connection from the client to the server. Then from the channel, you need to create a stub. So the stub can be blocking or non-blocking. In blocking stubs, when you make a request to the server, the call basically will block until you get a response. But you can also create a non-blocking stub where you instead of a blocking call, you actually get a call back. So you create your stub with the managed channel, then you create a request, and then you send the request using the stub, and then you get a response from the server either in sync mode or async mode, depending on your stub. And that's it. That's it really. So let me just show you this quickly in Eclipse. So here I have a project called Simple gRPC Server and Simple gRPC Client. And then first thing, let's look at the proto object. So this is the service definition. One thing to note is that first, the syntax I'm using is Proto 3. So Proto has different versions, but gRPC uses the latest one, which is Proto 3. And then you can define packages. So this package will basically be used for the generated code. So the generated code will have this package name. I also specified this Java multiple files. When gRPC generates code, by default, it puts everything into a single class. I don't like that because I like things to be separate. So by setting this flag, I'm getting classes in multiple files. Now let's look at the service. So the service, like I showed in the slides, it's called greeting service. And then we have the greeting method, takes in a hello request, returns a hello response. Now the hello request in this case is it's a little bit more complicated. So instead of just being a string name, we also have age, that's an integer. We also have something called repeated. So this is a list in gRPC. So we have a list of string for hobbies. And we can also have a map. So in this case, we have a map of key and values. And you can even have an enum. So in this case, we have an enum called sentiment. So the request is basically about a person with name, age, hobbies, and sentiment. And then the sentiment has to be defined. So we define the sentiment here as enum sentiment, happy, sleepy, angry. So this is our request. And then the response is just a string. So we'll get the request, and then response will just be a string from that. So this defines our service. And then from here, if you look at our POM file, as you can see, there's a Protobuf Maven plugin. I'm using Maven here. So this plugin will look at the service definition, and it will generate the code for us. And if you take a look under target generated sources, you see that there's a lot of code here that's generated for you. This is great news because this means that this is a code that you don't have to write yourself. So all the connection details, all the things about making a connection, sending the request, serializing, deserializing, all that kind of stuff is done for you. And if we look at the code itself, it's not great. I mean, I don't like generated code, and I don't look at it usually. But if you want to look at it, it's here. But usually you don't care because you're in Eclipse. You have strong types, so you can just use like code hinting and find what you need to find. You don't have to actually look at these classes yourself. The important thing is that, so let's look at how we create the server. So this is my gRPC server. So this is the class that you have to create yourself. And if you look at here, what we do is, first of all, we need to build a server. So here I'm using server builder. This is something given by gRPC to me. And I'm saying I'm going to use this port. So I'm using port 8080. And then I'm adding a service and then passing a new greeting service implementation. So this is the guy. This service implementation is going to define how my service works. And we're going to look at that shortly. And then from there, I just do build. So everything in gRPC is through builders. So you build builders, and then you call build on them to get the actual object. So this is something that you need to get used to if you don't like builders, but that's how it is. So once you have a server, then all you need to do is just call start, and service starts. Now, the important part is this greeting service implementation, because this is the guy that actually defines what our service is going to do. So let's take a look at that. It's right here. So one thing to note here is that the service implementation extends from this base class. So this is the base class that was generated by gRPC for us. So by extending from this, you get this greeting method that you need to override. So this came from the service definition. The service definition basically defined what this greeting should look like for us. And all we had to do is just implement this method, and we're done. So in this case, the greeting takes a request and returns what's called a stream observer. So this is basically the response to the client. And what we're doing here is that we take the request, and then we create a greeting from the request. So we say hello there. And then this request object, it's generated by gRPC for us, and it's strongly typed. So if I do this, like request dot, I can see that it's get age, get bagout tricks, get name. So you don't have to actually look at the request object. From here, you can figure out what you have access to. So here, what we are getting is basically just the name from the request. And then we need to generate a response to the client. So what we do is hello response dot new builder. Everything happens through builders in gRPC. And then once you have the builder, you call set greeting and then pass in the greeting that we just created, and then do build. So now you have a response that you can send to the client. And then you just use response observer. So response observer on next will basically send the response to the client, but it's not committed yet. So then I call onCompleted to make sure that the actual response goes to the client. So this is it for the server. As you've seen, all we had to do was build a server with a service implementation, and then we define the service implementation in the other method, and then call start on the server, and that's it. and the service implementation, it extends from the base class that was generated for us. And from that, we know that we need to implement this method. And then here, we basically just define what we want to do, and then create a response and send it back. Now, to look at the client side, so this is the client side. So what you need to do is first you need to create a channel. So you need to define how the client is going to talk to the server. In this case, we are saying we are using this channel builder, and then we are saying talk to this host and the port. And the host and the port are localhost and 880 here. I don't want to worry about HTTPS and certificates and stuff like that here. So that's why I'm using use plain text true. So this basically tells gRPC that this channel is for HTTP. But in real-world applications, you would use HTTPS. But for this demo, I'm just using HTTP. And I just call build. So I have a channel that I can use. Now, from the channel, I need to create a stub that the client needs to use. So in this case, I am creating a blocking stub because I want to make a request and make sure that I get a response. I want that to block. So I just, again, using the generated code, I just say, OK, give me a blocking stub and use this channel when you make that connection. So the stub will use this channel basically to talk to the server. So now that I have stub, basically that's all I need to worry about as the client. Like the client talks to the server through the stub. Now, what I want to do is I want to send a request to the server. So again, I go to my hello request that was generated for me, get a new builder, and then from the builder, I have all the things that I can set on it, right? Like if you do the .set, you can see all the stuff that I can set on it. In this case, I'm setting my name, my age, my sentiment is happy, and I do build. So I have my requests. And I just basically do stub dot, and then it's strongly typed, right? Because everything is strongly typed in gRPC. So from there, I know that I have this greeting method that I can pass in a request. So I just call greeting and pass in my request. And since this is blocking, it will basically block here until I have a response. And once I have a response, from the response, again, it's strongly typed. So from the response, I know what to get. I'm getting the greeting. So basically, I'm making a request, and then I'm getting the greeting from the response. And then once you're done, you just shut down the channel. So that's it. And let's just run this quickly so that you see that it works. So go here. So server started on port 8080. And the client, now when I run it, it will create a request, send it, and get a response. Sending request, receive response, hello there, and my name. So it's very simple. And let me just stop the server. I'll go back to my presentation. So this is like hello world in gRPC. Now I want to talk about the benefits. So what benefits do you get by using gRPC other than just the generated code for you? And the benefits is, number one, HTTP2. So the whole point of HTTP2 is low latency transport of content. So there are many features in HTTP2 that tries to make the end user perceived latency much better than HTTP 1.1 or 1.0. And actually, there was a talk before now that talked much more about this than here. So if you're interested, make sure you watch that video. It was a good talk. One of the things that's important in HTTP2 is that it tries to use a single connection. Because normally, if you want to make a lot of requests to the server, you make multiple connections. But here in HTTP2, there's a single connection, and there's true multiplexing. What that means is that if you send, let's say you send 3 requests, request 1, request 2, request 3. If request 1 takes a long time, then your request 2 and 3 will block, basically, before HTTP2. But in HTTP2, it basically doesn't block. So if your request 1 is taking a long time, request 2 and 3, if they take shorter, then you will get responses for those in a much quicker way without having to wait for request 1. So that's it. And then what this means for you is that when you download a picture, This is how it looks in HTTP 1.1, and in HTTP 2, that's how it looks like. And actually, there's a cool page. If you go to this page, you can run like live demo. So this is being downloaded in HTTP 1. It took 2.48 seconds. If you run the same one in HTTP 2, it takes like 0.39. So that's really nice. So this is basically the connection efficiency that comes with gRPC. The other efficiency that comes with gRPC is what goes over the wire. So gRPC uses protobuf. It's a binary protocol, and it's much more efficient than your regular XML or JSON. This is a graph from one of the Google Cloud services. They used to have an HTTP 1.1 JSON-based endpoint, and this was their throughput. And then they also created a gRPC-based protobuf endpoint, and then their throughput basically jumped to from 30-something to almost 120, because what goes over the wire is much smaller. What you need to serialize is smaller. What you need to deserialize is smaller, so you use less CPU. So by just using a binary efficient protocol, you're just getting like benefits like this where throughput increases. So that's efficiency over the wire. And the last one, and I think it's a really important one, is the multi-language support. So all these languages, C++, Java, C#, PHP, they all have implementations in gRPC. So you don't have to pick a language, basically. As long as it's one of these, you're pretty much covered. And I think that's important because in my case, I was using ActionScript and Flash. When Flash went away, then I had to do all of the work again. But now here, like with gRPC, you have all these generators that's done for you, and that's great. And the last one is the connection options. So you don't have to do just request and reply. You can do server-side streaming. You can do client-side streaming. You can do bidirectional streaming, which is nice. And let me just show you how that works. So imagine you want to write a chat application where people are chatting to each other. In that case, you need a bidirectional streaming because your clients can send messages to the server anytime. And then your server, when it gets the message, it needs to send that to connect the clients anytime. So it needs to be bidirectional. So to do that in gRPC, remember in Flash, I had to create all these new channels and do all that work at the channel level to do it. But in gRPC, it's much simpler. What you need to do is, I have this sample here, chat server and chat client. So let's look at the server first. So first, we need to define the actual service. Let me close the other ones. So we have this chat service. It has a method called chat, and it takes in a chat message. So this is the message from the client, and then it returns a message from the server. So that's the message from the server. But one thing that you're going to realize is that we have this stream keywords. So by marking this message as stream, we are basically saying that the message, the connection between the client and the server, it's a streaming connection. And also by marking this one as stream, we are saying that the connection from server to client is also a streaming connection. So it's a bidirectional streaming connection. So all you have to do is just basically mark your messages with stream, and that's it, you have bidirectional streaming. Now, if you look at what these guys are, the chat message is basically, it has a from, so who's sending the chat message, string, and it also has a message, which is a string. And then the chat message from server, it has a timestamp. So when the server gets a message, it will timestamp that. And then the actual message that was sent from the client. So this is our definition for our service. And let's just look at the code real quickly. So if you look at chat server, it's very similar to before. We, again, build a service with the port, which is 8080 again. We add a service, which is chat service implementation that I'm going to show, and we build, and then we start the server. It's identical to Hello World, but this is much more complicated. It's not Hello World, it's a chat application that's bidirectional streaming. But when you look at the code, it's pretty much the same. If you look at this service implementation, again, it extends from this generated code, and by extending, we get this method this time. So this method, it's a little bit different than before. It's called chat, but it takes in a chat message and returns, it takes in a stream observer and it returns a stream observer. So stream observer is the abstraction that we use to define the streaming connection, basically. So what we do is, when we get a response observer from the client, we add it to our observers. So these are basically our connected clients. So we keep that in a set. And then this stream observer will basically defines what we're going to do on the server, what we're going to do when we receive a message from the client. So on next is when we get a message from the client. What we are doing is we were printing the message for debugging, and then we're gonna take the client message and we're gonna create a server message out of it. So we create a new server message. We set the message to what we received from the client, and we also timestamp that, and then that's it. So we built that, and then once we have the message from server to client, we'll just call observer.onNext and pass in the message. So we'll basically create the message on the server and pass it to all connected clients, and that's it. And on error, I'm not doing anything right now, but normally you would log it and send some kind of error message. And then on completed is when the client disconnects, then we just remove the client from our list of observers. So this is the server side. And then if we look at the client side, so we have this chat client, and we are using JavaFX here. So there's lots of UI code here, but we don't care about that. Let's just look at the actual gRPC code. So as before, we are creating a managed channel for the host and the port, and we are using HTTP, not HTTPS. Now from the generated code, we get a new stub, but the difference in this case is that it's not a blocking stub anymore. It's non-blocking, because in a chat application, you don't want to block. You want to get callbacks. So from there, we get a chat service, and then we call the method. It's strongly typed. So from here, I can see what I can call. So there's a chat method that we created on the server side. So we call that, and we pass in a stream observer. So this is basically the handler for the messages from server to client. So what is the client going to do when it receives a message from the server? So what it will do is, again, it's strongly typed, so I know that I need to implement this on next, on error, and on uncompleted. So on next is when I receive a message from the server, I'm basically just displaying that in my JavaFX application. And then on error, I just print the error and just say disconnected, and then on completed, I say disconnected as well. And then the last thing is that when the user, we're going to have a button for the text. So when the user types a message and hit sends, what happens? We create a chat message. So again, from chat message that was generated for us, we get a builder, and then say from message and build, and then we have this chat object that we got from this chat service earlier. So we just pass in on next. So we are basically just creating a chat message and sending to the server. And when we close the actual chat application, we call on completed. So we are basically letting the server know that we are done. You can close the connection. So that's it. And let's just run this again quickly. So let's start the server. So server is running. And then let's start the client. And let's start 2 clients because it's not nice to chat by yourself. So this is client 1. This is client 2. Let me move them a little bit. So this is, let's say it's me. And then it's you. And if I say hi, then right away the other guy gets it. And then hi back. You get it. So you have the streaming connection. So every time you send a message, the other guy gets it right away. All right. So let me just go back to my presentation quickly. So this shows you that you have different connection options, basically. And that's it. That's all I had to say. There's a page, gRPC.io, where you can go and, depending on what language you use, there's lots of samples and quick starts. And if you want to contribute, as I said, it's open source. So feel free to contribute yourself. And my Twitter and my email, if you have any questions, let me know. I think we have time for some questions. So if you have any questions, let me know. Yes?
What happened during a deconnection? Your server crashed and then restart?
What happens when you have a connection and the server crashes? the client will get like an on disconnect, so the client will be disconnected basically. So there will be an error message. Yes?
How does it manage optional values or required values?
How does it manage optional values? And there are no optional values. So the message has the values, so you have to pass them in. I don't think there's any optional values. Yes?
Is gRPC feasible for communication between microservices? I'm thinking of separately deployable and backwards compatibility between
Yeah.
upgrading server sizes.
Yes, so the question is gRPC compatible with microservices that can independently update, right? That's the question. Yes, I mean, it is designed for that because you have the service definition file that everything, the client and the server code gets generated from, right? So if you need to change the service, you just change one file and you regenerate what you need to regenerate, and that's it.
Then you need to deploy.
Yeah, yes. I mean, of course, yeah, you need to do versioning and things like that, but all that kind of stuff is you need to still do it. But at least like updating the service itself, it's easier because you don't have to. You just have to worry about changing the service definition file, and from there, all the connection stuff is auto-generated for you, so you don't have to change a lot of code. Yes.
Is there nothing special in here for versioning itself?
There's nothing in gRPC special for versioning, so you still need to do that yourself. Yes?
Are you looking at the reactive streaming API put in here?
So,
So I learned the talk from a few days earlier that presented the reactive streaming API, and it's basically the same what you're doing, but with a few differences.
yeah, so the question is, how does reactive stuff relate to gRPC, basically, right? It doesn't really play well with reactive stuff, gRPC. Maybe someone will come along and they will write something that will make it easier, but for now, I don't think there's anything in gRPC that plays well with reactive. Yes?
Is it possible to customize the authentication between services?
Is it possible to customize authentication between services? I think it is possible. I haven't done it myself. I know that the usual TLS stuff works and that there's token-based authentication as well, but you can plug in whatever you want. You just need to implement that yourself. Yeah, I mean, the whole thing is open source and it also tries to be pluggable. So whatever doesn't work for you can pretty much plug in and write your own implementation. More questions? All right, I think that's it. Thanks for your time, and yeah.